what actually happens the moment an AI agent's conversation gets too long for its context window. Most people assume it just crashes or silently forgets the beginning. The real answer in Hermes Agent is a deliberate multi-phase process with its own anti-thrashing guardrails, its own cache-aware math, and a summary format specifically written to stop the model from getting confused about what's real. Today we open the file that runs all of it. Welcome back to the Hermes Agent Deep Dive. Part 2, open the loop that drives a single turn. Part 3, open the system prompt that loop sends every time, and the caching promise built around it. Build once, reuse until something forces a rebuild. This part is about that something. What happens when a session runs long enough that the cached prompt and the growing conversation together no longer fit? Every file and line number on screen comes straight from the pinned v2026-7 release of NousResearch's Hermes Agent, so you can open the same source and check it yourself.
By the end of this part, 5 things should click. When context compression actually fires, and why the trigger threshold is computed from the model's real usable input budget, not a flat percentage of the whole window. What the compressor protects at the head and tail of a conversation, what it prunes for free before calling any model, and what it hands off to a cheaper auxiliary model to summarize. Why every compacted summary ships with an explicit block of instructions telling the main model not to treat old, already finished work as something to resume. How Anthropic specific prompt caching sits on top of all of this as a separate, complementary optimization. And how a totally different module reuses the same token estimation logic to show a live, cursor-style breakdown of exactly where a session's context budget is going. Strip away every helper function and one compaction pass does 5 things in order. First, prune stale tool results for free, no model call required. Second, protect a head window, the system prompt and the first exchange, left completely untouched. Third, compute a tail window size by an actual token budget, not a fixed message count, so recent context always survives intact. Fourth, take whatever's left in the middle and hand it to a cheaper auxiliary model with a carefully structured summarization prompt. And on top of all 4 of those phases, Anthropic prompt caching layers its own separate set of breakpoints onto whatever messages remain, so the provider can reuse work across turns. Head and tail never change, only the middle ever gets rewritten. A few things will help before we dig in. Python 3.10 or newer, and your own clone of Hermes Agent, checked out at tag v2026.7.1 to match every line number we cite. Have all 3 files open side by side, context_compressor.py, prompt_caching.py, and context_breakdown.py, because together they cover the full lifecycle of a session's context budget. It also helps to already understand roughly what prompt or prefix caching is, and why providers charge less for tokens they've already processed before, because that's the entire reason both compression and caching exist in this codebase. Watching part 3, on the system prompt, first will help you place this in context. Start with the Docstring, because it tells you this isn't the file's first version. It's self-contained, with its own client for summarization, and it uses a cheaper auxiliary model, not the main model, to do that summarizing while protecting a head and a tail. The comment block underneath lists real improvements over an earlier version, a structured summary template that tracks resolved versus pending questions, iterative updates so a session can be compressed more than once without losing earlier context, token budget tail protection instead of a fixed message count, and cheap tool output pruning before any LLM even gets called. Each of those 4 improvements gets its own code step in a minute. This is Context Compressor's Constructor. 4 defaults matter most. Threshold %% at 0.50 means compression is allowed to trigger once a session crosses half of its usable budget. Protect _first_n at 3 keeps the earliest messages, typically the system prompt and the opening exchange, untouched. Protect _last_n at 20 is a message count fallback, but as you'll see, the real tail boundary is computed in tokens, not message count. And summary_target_ratio at 0.20 caps how large the generated summary itself is allowed to be, relative to what it's replacing. Every one of these can be overridden, but the defaults alone tell you the design's priorities. This is where that 50% number gets turned into an actual token count, and it's more careful than it looks. The function starts from an effective window, the model's context length minus whatever max_tokens the provider reserves for its own output, because that output space isn't available for input in the first place. 50% of that effective window becomes the raw threshold, then it's floored at a constant called minimum_context_length, so a huge context model doesn't compress prematurely, and a small local model doesn't get a threshold so low it triggers constantly. Here's the edge case the comment walks through directly, referencing a real tracked issue, number 14690. On a model whose context length sits right at that minimum floor, the math degenerates, 50% of the window, floored at the minimum, equals the entire window. Compression could never fire, because the provider would reject the request before usage ever reached 100% of a threshold that already equals 100%. The fix, when the floor would meet or exceed the window, trigger instead at 85% of it. High enough that a small model still uses most of its budget, low enough that compaction fires before the provider does. Before any compression runs, should _compress has to say yes. The obvious check is whether tokens have crossed the threshold we just computed. The less obvious check is anti-thrashing. If the last two compression passes each saved less than 10% of the window, this function refuses to run again. Without that guard, a pathological conversation could compress over and over, each pass trimming one or two messages, burning an auxiliary model call every single turn for almost no benefit. This one comparison is the difference between a session that compresses cleanly once and a session that quietly loops forever. This is compress, the method that actually runs a pass. Phase 1 prunes old tool results for free, no model call needed for that part. Phase 2 finds the two boundaries that matter. Compress_start comes from protect_head_size, the untouchable opening messages, and compress_end comes from find_tail_cut_by_tokens, which walks backward from the end of the conversation until it's collected a real token budget's worth of recent messages, not just a fixed count of them. Everything strictly between those two boundaries is what actually gets summarized. This constant is one of the more interesting design decisions in the whole file. The generated summary doesn't just get dropped into the conversation as plaintext, it's wrapped in this exact preamble, telling the model in no uncertain terms that everything below is reference only, not a new instruction to act on, and that only the latest real user message after the summary is the actual, current task. Without this wrapper, a model reading its own compacted history could mistake a stale, already finished request for something it still needs to go do. That's a real failure mode worth defending against explicitly, not just hoping the model figures it out. Compression decides what's even in the conversation. This function, in a completely different file, decides how Anthropic specifically gets to reuse whatever survives. The strategy is named system_and_3, up to 4 cache_control breakpoints total, one on the system message and one each on the last 3 non-system messages, all sharing the same time to live, either 5 minutes or 1 hour. It deep copies the messages first so the original conversation object is never mutated, then walks the list marking exactly those 4 positions. The header comment on this file states the payoff directly, roughly a 75% reduction in input token cost on multi-turn conversations within a session. A few notes before you build on this pattern yourself. Pin the exact tag or commit your citing token budget. Math like this tends to get patched the moment a real production session exposes an edge case, exactly like the 14690 issue we just walked through. Don't just crank threshold_% toward 100% hoping to delay compression forever, you'll eventually hit a provider's hard context limit with no graceful fallback in between. Treat that anti-hijack summary prefix as load-bearing, not decorative boilerplate. It's actively preventing a real confusion failure mode. And remember, prompt caching and context compression are two independent systems solving two different problems. Tune each one on its own terms. One practical habit: if you're running Hermes Agent yourself, just tail the log and grep for the phrase context compression. Every real compaction pass logs both the trigger, how many tokens crossed, how large a threshold, and the model's raw context limit alongside the percentage that produced it. Watching this over a few long sessions tells you fast whether your threshold percent and protect_last_end settings are actually matching how you use the agent, instead of guessing from the defaults alone. Let's pull it together. Context compression in Hermes Agent isn't a flat percentage cutoff, it's computed from the model's real usable input budget, with an explicit 85% escape hatch for small context models that would otherwise never trigger. Anti-thrashing stops the whole system from looping when a session genuinely can't be shrunk any further. Every generated summary ships wrapped in an instruction block that keeps the model from mistaking old, finished work for a new task. And Anthropic's prompt caching sits on top of all of it as a separate, complementary optimization, rewarding whatever survives compaction with cheaper reuse across turns. That's context compression and caching, the The part of Hermes Agent that keeps a long-running session usable and affordable instead of quietly overflowing, straight from the pin source with every line cited. Part 5 goes in a different direction, runtime_provider.py, the single interface that lets this same agent talk to 18 or more different model providers through one consistent surface. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in Part 5.